Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. Okay, so this is a new problem in front of us. Problem number 17, letter combinations of a phone number. Medium problem, I would say for a first timer. Yes, it can be considered as a medium problem. 14,000 upvotes, you can see. Previously asked in, you can see 25 times Amazon, that is just recorded on lead code. So technically you can see how important it is as a problem statement. Microsoft, Facebook, Google, Apple, Bloomberg, Twitch, Oracle, DShaw, Walmart, Swiggy, and previously, like last year or 2 year back, it was the one of the favorite questions, you can see. Like during my time also, people used to be like, this question is one of the most highly asked question in on campus interviews or off campus interviews. So kind of very important problem. So what the problem says? The problem says that given a string containing digits, so you have digits in the string from 2 to 9. So you'll be having only 2 to 9 as the digits. You need to return all possible letter combinations of that number could present. So you need to figure out all possible letter combinations that the number could be showing you. Now, what is a letter combination? What will be the letter combination? For example, let's say if you have 2, 3 as the digits, 23 are given in the string, one digit is 2, one digit is 3. Now, in earlier Nokia keypad phones, the keypad used to look something like this, whereby pressing 2 some number of times, you can either form the character A, or you can form the character B, or you can form the character C. Similarly, by pressing 3 multiple number of times, you can either form D or E or F. Similarly, by pressing 7 multiple times, you can get either P. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our system design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. Q or R or S, right? So when they say 23, they say that by pressing 2 some number of times and by pressing 3 some number of times, what possible combination of alphabets you can get. For example, if you press 2 once and 3 once, you get AD. See, you can get A, you can get D. Now let's say you pressed 2 once and 3 twice, you get AE. You pressed 2 once, 3 thrice, you get AF. You press 2 twice and 3 once. So 2 twice gives you B, 3 once give you D, so BD. You press 2 twice, 3 twice, you get BE. You press 2 twice, 3 thrice, you get BF. And at last, similarly, you press 2 thrice, 3 once, so you got CD and so on and so forth. So technically, by pressing the digits of the phone, how many different word combination using the characters that are allocated to those digits you can make, you need to print all of those. Right, you need to store, you need to store everything in the form of an array and return. So technically we can say they are expecting us to somehow print it. Okay. Now, how can we do this question? Now we know that we have a set mapping. This mapping is never going to change. We know that 1 is not mapped to anything, 2 is mapped to A, B, C, 3 is mapped to D, E, F, 4, 5, 6 and so on, G, H, I, J, K, L, M, N, O and so on. Right. This mapping is given to you. Now when you get a string 2, 3, now what you can do is, I don't know in how many ways you can create the mapping of 2, 3, right? I don't know about this. So I say that I don't know in how many ways you can create the mapping of 2, 3. But if you can give me all the mapping combinations of just 3, what are the mapping combinations of just 3? D, E, F. So if you give me mapping combination of just 3, in front of all of those, I am going to play the game for 2. What is a game for 2? The game for 2 says that 2 has a mapping of A, B, C, right? So in front of all of them, I will once attach A. I will once attach B. I will once attach C. So if you attach A in front of all of those, you get AD, AE, AF, BD, BE, BF, CD, CE, CF. Okay. So in front of all of these, we have been able to attach these set of characters, right? So don't you think this strategy looks a lot like subsequence, but this time instead of having the character 2 getting attached and not getting attached, we are going to fetch the mapping of 2. What is the mapping of 2? You can store the mapping of 2. And then from that mapping of 2, I'll first attach the first character of the mapping to every character of 3. Then second character of mapping to every character of 3. Then third character of the mapping to every character of 3. Let's see it in a wider perspective. Let's say I want to get all the possible combinations of 2, 3, 4. Okay. I don't know what are all the possible combinations of 2, 3, 4. So if you give me all the possible combinations of 3, 4, if somehow Like I don't know about 2, 3, 4. But if you give me all possible combinations of 2, 3, 4, no? Then in front of all the possible combinations of 3, 4, I will once attach one character of 2, I will once attach another character of 2 and so on. So what is the combination of 3 4s that you can get? Let's see. So 3 is DEF, 4 is GHI. So the combinations will be DG, DH, DI, EG, EH, EI, FG, FH, FI. We will assume that this 3 4 combination will be created for us. This combination will be created for us without a fail. What we can do is, in front of all of this, what are the characters of 2? A, B, C. I will once attach A and send. I will once attach B and send. I will once attach C and send. So I will say that I want to create combinations of 2, 3, 4. Please go and bring me all the combinations of 3, 4. In front of all of those combinations, I'll attach A, I'll attach B, I'll attach C. So if you attach A, you get, I'm not writing everything, but still I will try to write ADG, ADH, ADI, AEG, AEH, AEI, AFG, AFE, sorry, AFH, AFI, then BDG, BDH, BDI, BEG, BEH, BEI, BFG, BFH, BFI. Similarly, CDG, CDH, CDI, CEG, CEH, CEI, CFG, CFH, CFI. Can I say that? You just need to append in front of all of this. And this appending strategy we have already discussed in subsequences, where we used to get all the possible subsequences of BC and we appended A in front of all of this. And once we didn't append anything. This time we don't have a strategy of not appending anything, okay? Now you might be thinking, okay, how will we bring the combinations of 3, 4? For that, you will say that bring me combinations of 4. Give me all the combinations of 4. What are the combinations of 4? Combinations of 4 are G, H, I. 3 combinations are there. So what I will say, in front of all of these combinations, I will once attach D. When you will attach D in front of them, DG, DH, DI. I will once attach E, EG, EH, EI. I will once attach F, FG, FH, FI. Now you will say, I don't even know the combinations of 4. So I will say, bring me the combinations of empty string. Now the combination of empty string is going to be what? Empty, right? And in front of this empty, I'll attach GHI. So G with the empty string becomes G, H with the empty string becomes H, I with the empty string becomes I. This is kind of like the thinking I want you to create. So if I write a function f of str, of course we have the str, we have I to iterate on the string and get the digit, and we will prepare output. Okay. And you can keep a global mapping. You can store that in a vector. Okay, you can store a global mapping. How we can implement this function? We say that, let's say you have 2, 3. So what does this function represent? This function represents that starting from the 0th index to the last index, give me all possible combinations. So compute all possible keypad combinations of the string from index I to n-1. So I want to compute all the combinations of 2, 3 from 0 to n-1. I will say that you go and compute all the combinations of 3 all the combinations of 3, all the combinations of 3, right? Can I say when you say 1, then starting from the first index till the last index, you get the combination that is just 3. In front of all of them, I will once attach A, I will once attach B, I'll once attach C, because if you see the mapping of 2, it is A, B, C. So I will say A here, B here, C here. Then I don't know how to get the mapping of 3, so I will say that go and bring me all the mapping of empty. Empty. And in front of all, I will once attach D, then E, then F. So I already attached A, now I'm attaching D, so this becomes AD, AE, AF, and similarly 3 more calls will be there. Similar implementation we can do. So if I write the recurrence, we can say that this is going to be equal to F of str of I plus 1. We are going to assume that the function works correctly for I plus 1 comma output plus character for all character that belongs to mapping of digit at ith index, right? So I will once attach it for A, then B, then C, and so on. We'll repeat this process, right? So let's try to code it. Let's try to code it, and then we will be able to get a better understanding, right? I'll just directly code it on lead code. Let's select C++. I will say that now I want a 3 parameter based recursion function, right? This is only 1 parameter, so I'll write my own function. I'll say void f string str int I string output, right? And then we can say that if I becomes equals to str dot size, this is the base case, right? See, this is the base case. So when I become equal to the length of the string, in the output we have one possible combination. Okay, so for the timing I'm just printing. Okay, for the timing I'm just printing the combination output and return. Otherwise what we are going to do, go to the mapping of str at I digit. Okay, so let's get the current digit. Okay, let's get the current digit. How can you get the current digit? You can say str at I minus 0. So from the ASCII of the current digit, I'll subtract the ASCII of 0. This will give me the current digit. Then now we have the digit, and let's first of all create a mapping. So to create a mapping, I'll create a vector of string. Okay, mapping. And let's say on the 0th index, I will not keep anything. On the first index, I will not keep anything because 0 and 1 don't have any characters. On the second index, I'll keep ABC, DEF, GHI, JKL, MNO, PQRS, TUV, WXYZ. See? Vector. So we have created this mapping, right? So if I want to get the characters of the mapping, so I'll say string characters of mapping. This will be equal to what? Mapping of the digit. Can I say that? For example, our digit comes as 6. So on the 6th index, we have MNO. So we will get MNO inside the string. So for example, if the digit is 6, then here I will store MNO, right? Now all I have to do is iterate over MNO. Let's say int j equals to 0, j less than characters of mapping dot size j plus plus. Okay, And then what I'm going to say is, I'll say that go and bring me the combination of rest of the characters in front of everyone. I will once attach M, I will once attach N, and I will once attach O. That's it. That's it technically. So from this, I will call F of digits, comma 0, comma empty string. Let's see what is the output coming as. Okay. If you run, okay, it's an error. It expects us to return a vector. So for the timing, I'm creating a result vector. Result. In lead code, if you will not even write std, it will work. I'll like this is something called as namespace. We can discuss it later, but just if you are getting confused about std, then on lead code, if you will not even write std, it will work. At last, I'm going to just return result so that we are able to at least compile. Okay, can you see I am printing everything? AD, AE, AF, BD, BE, BF, CD, CE, CF. This was the expected output. I don't have anything in the result, but I'm printing everything. Why? Because I printed it here. Now, instead of printing, if I store this in result dot pushback output, and then I run, then you can see we are getting the correct answer. So we have implemented it successfully, right? There is only one thing that we need to do. Whenever in lead code you are making kind of like these variables which are class variables, or you can see for the time being global with respect to the function. So every time if you have a variable in which you are storing your result, make sure you reset the variable. Otherwise the global variable becomes polluted. Okay. So all we have to do is just do result.clear. So there is a function inside vector known as clear. It just removes if there is any garbage value inside the vector. If you run it, okay, this is semicolon. So let's submit. Okay, so this is a corner case. What if you have an empty string? In case of empty string, you just need to return empty vector. So we'll say that if digits.size is equals to 0, we just return result. I guess this is the only corner case, and that's it. You can see we have implemented the whole solution, and in a very clean fashion we have implemented it. We kept a mapping, we kept a result. In the result, we kept on pushbacking. If you don't want to prepare this result as a global variable, you can pass this result in a function. I generally don't pass it in the function in tutorials because I want to keep my implementation as close as possible to the recursive relation that I write here. So I hope this problem actually makes sense to everyone. Now let's start with the base case. Okay, for the timing, we'll write the base case like, I'll change this base case in a moment. But if index becomes equals to str.length, what you are going to do? Let's say for the time being, I'll print output and I'll return. Otherwise, what I'll do is I will ask for all possible combination from idx plus 1 to the last character, and in front of all of those, what I'm going to do is I'm going to append my every character of the mapping. So int k equals to 0, k less than map of, now what is the digit? Let's get the digit in digit. So the current digit will be str dot char at idx. This is the current digit, but in the form of a character. If you subtract a single quoted 0, it will become a string, right? Because you will be able to subtract it with respect to ASCII. And now I'll say map of digit dot length k plus plus, and then every time this function call will say output plus. Now once I'm going to prepend digit of 0, then digit of 1, then digit of 2. That means once I'll append A, then I'll append B, then I'll append C. As simple as that. Okay. Now, if you carefully see, if you will run this code, it should work fine, but it doesn't comply to our return type, right? Our return type is what? A list of string, right? We always have to return a list of string, and currently we are just printing. So what you can do is you can pass an argument for a list of string here as a fourth argument, or a lot of times you will find me doing this. You can say public static list of string. I'll make it a global, right? And one more thing, if you see, what is this? This map is an array. On this array, you have this digit, which is going to be a number. So you are going to access an index of this array. If you see what is stored inside an index of this array, it is stored as a string. That's why I've kept it a length. So just for clarity. Okay. And I'll say result is equals to new array list. Okay. New array list of string. Okay. So we have kept this result, and instead of doing a print on this result, I'll say result.add output. Okay. And now from here, what I'll do is I will call for f of digit starting from index 0, initially everything empty, and I'll return result. Okay, let's see what happens. Let's see what happens. Okay. Oh, I'm not signed in. Let me just quickly sign in here. Okay, so I've signed in now, and let's try to run this code. Okay, there is an error. We have missed a semicolon. Okay, let's see what more errors are coming. Oh, you don't have anything like it says cannot find symbol str. Okay, let's just quickly check what's going on. We're calling for f. Str.char this -0, and we do map of digit dot length k plus plus. Interesting. Why it says str.char is not available. Okay, let's go on this again. So what I did here is I want to extract what is the current digit. For example, let's say if it is 2, I want to extract the current digit. That is, if you do str.char at idx, you get a 2 as a character. You get 2 as a character. Now I want to store this 2 as a digit or a number, right, or an integer. So what I'll do is I'll subtract it with a single quoted 0. So there will be 2 ASCII subtraction that will be going on, right? So if I show you on an online ID, maybe let's say let's go to ID 1. Okay, so let's select Java. Where is Java? Okay, let's say I have a string 23 and you have a string s23. If you do system dot out dot println and you do s dot char at 0, okay, and you run it, so you are going to get the 0th character, right? What's the 0th character? It should print 2. Oh, not cat at, it's char at. It should be char at. Okay, let's wait for it to compile. Nowadays IDEON is pretty slow. See, we are getting 2 character, but if you want to convert this to a number, what you can do, you can subtract a single quoted 0 in front of it. Why? If you see the ASCII table, characters are internally stored as in the form of an ASCII. So if you see the ASCII table of this, see ASCII of 2 is 50 and ASCII of 0 is 48. If you do 50 minus 48, you will get 2, right? So if you will subtract a single quoted 2, that is a character 2, from a character 0, you will get integer 2, because if you subtract two characters, they do ASCII subtractions. Okay. So if you run it again, if you ID on it again, you'll still get the answer as 2, but this time it will be a number instead. Okay. Now let's come back to our problem and let's see what mistake we might be doing. So we have char at idx. Oh, I wrote cat at. This was char at. My bad. Okay, yeah, that issue is resolved. Let's come back here. Now what do? We do map of digit. What is map? It's an array of string. Digit is going to be some possible index, right? So then on that particular index, you try to access this. So this is a string, right? So we have to do char at. Okay, because map of digit is what? A string. Map of index 3, let's say, it's a string. So string dot char at. Okay, and you can see everything looks pretty good, but there is a problem with this solution, right? Let's try to submit it. If you'll try to submit it, you can see it shows a pretty weird answer. Why? If you will try to execute this same test case here, you will get the correct answer. See, we are getting correct answer, right? But here we are getting all of this A, B, A, E, A, F, B, D, B, E. Here we are just getting empty string, right? Although we have to still resolve it, because even for the empty string, we should not get it. But the problem here is that this result array is a static array in the class, right? If you don't know about static and everything, don't worry. For the time being, you can assume it's kind of like a global array, right? What LeetCode does with your solution is that it runs this same function for multiple test cases. If it runs the same function with the multiple test cases, this global array will be polluted again and again. With the first test case, the answer will be inside the global array. The moment it runs the second test case, that answer will be appended after the answer of the first one, because it's a global array. Whatever you add inside it, you never remove it. It's not a local array, right? It's not like a local array list that you have actually prepared here. So that's why a lot of time you'll find people and myself also doing this, that before you run this function, we can just clear the result array. That is, if anything is already present inside result, we will clear it out. Okay. And one corner case we can actually put, if digits dot size, or let's say digit dot length, is equals to 0, you can directly return result. You don't need to do any computation. If now you run the code, this test case also works, and even if you now submit, that problem will not persist, and you can see everything is submitted. And why is that? Because now we have handled one corner case of 0 length string, that you need to return an empty array, and we are doing result.clear. This is to make sure that when multiple test cases run on the same function, you don't have your global array polluted with the answer of the last test case while computing the current test case. I hope this solution is, again, whatever I said is whatever I wrote, and it is clear to everyone as well. Okay, let's say this is the corresponding code. Let's try to dry run this. Okay, let's say we have a call stack. Okay, from our main, I will call letter combination of 2 3. Okay, that is this function. Okay. Now we have a global result array or a array list, whatever you want to say. We clear it. So if there is anything, we clear it out, right? Then we check, is the length of digits equal to 0? No. So we are technically doing this computation here. You're inside letter combination and you got an input 2, 3. So is the length of the input 0? No. So what do you call? You call for f of digit comma 0 comma empty. So you call for f of 2, 3 comma 0 comma empty. Okay. Now let's see. So your f of 230 empty, and this 23 is also a string. Okay. What is index? Is the index equal to the length of the string? Is 0 equal to the length of 23? No. You extract out a local variable digit. What is digit? str.char at idx. What is str.char at 0? 2 minus single quoted 0. This will give you an integer 2. This will give you an integer 2. Okay. Now you start a for loop, k equals to 0. K equals to 0. Okay. You will check, is 0 less than map of digit dot length? What is digit? 2. What is map of 2? def. So what is def dot length? 3. Right. So you will check if k is less than 3. Yes, k is less than 3. So you will make a call for f of str comma, what was idx? 0. So idx plus 1 is 1, and str is also 23. And now what will you do? Inside your output, what will you append? Map of digit. What is digit? 2. So map of 2 is def. So def dot char at k. What is def dot char at k? D. So I'm going to append d here, and we will leave this on line number 15. Okay. Now, is 1 equal to the length of the string? No, 1 is not equal to the length of the string. What is a digit? Digit is equals to str dot char at 1. What is str dot char at 1? 3. 3 minus single quoted 0 is equal to 3. Okay. So you initialize another variable k equal to 0. Is k less than 3? Because def, map of 3 is def. So if df is dot length is 3. So is k less than 3? Yes. K plus plus. You will call for f of this comma 2 comma. Now what we are going to append? Output plus. What is output? D. So inside D we will append map of digit is what? Digit is 3. So map of 3 is def. Def dot char at k. What is k? 0. What is def at 0? D. Right. So, oh sorry, my bad. This should be appended with a, right? My bad. Because digit of 2 was ABC, right? So this should have been a. And after a, I will append d. You got ad. You got ad. Okay. Now, is index equals to the length of the string? Yes. 2 is equal to the length of the string. What do? You add your output inside result. So you add ad here and you return. Okay. You come back here. You left this on line number 15, right? You come back to this call. You come back to this call. After line number 15, what will be executed? Again, you will go to line number 14. You will increment the value of k equal to 1. Is 1 less than 3? Yes. So you again make a call to f of 23 comma 2 comma map of digit. What is digit? 3. What is map of 3? def. Def dot char at k. What is k? 1. So what is the character at the first index? E. So you got ae. And then 2 is equal to the length of the string. You append ae and so on. This is how you are going to actually proceed further. So this digit is going to actually help us to find the index inside map. And then when you do map of digit gives you some possible string here, and on that string you apply dot length or dot caret, whatever it is. These are the possible strings. I hope this dry run is clear to everyone.